So,
Sorry, Mark, I
yes.
have a couple of questions.
Yes, I think we can definitely have them as part of the group
Okay.
discussion in some sense. Yes. So, please.
How do you want to get the microphone?
How we do the microphone? That someone runs while I stay near the computer.
Thanks. This is really interesting stuff, and there are clearly a lot of very thought-provoking issues here. I don't even know where to start in terms of the comments that I have. There are a lot of things that I'm...
Well, if they're very, very long, maybe
So,
you can, yeah.
You know, one of the key questions, what do you really mean by OO? Do you accept the risk of substitution as, you know, the idea of sound subtyping, preserving contracts as being integral to OO? Or are you one of the people who thinks that OO is about reusing code, not about preserving contracts and behavior? You need to, you know, somewhere you've got to make a stand on that.
So
and
yeah, we're going
if
to
you're going to preserve contracts and behavior, then a lot of the things that a lot of people think of as being OO are not going to work. But then again, if you think it's all about reusing code and nothing else, then you're not interested in formal methods or verification anyway. So, you know, all this.
So, sorry, I have to argue against this last thing that you say, because I have worked with code verification, code reuse a lot, and I really care about verification. So I am simply...
Sure, you can do code reuse in a context where you care about verification and contracts, but a lot of the people who argue that OO is about code reuse will just substitute any piece of code
and that's my Thanos snap in some sense.
It's a piece of code that they want, totally irrespective
I understand.
of where and
in some sense, this is really my Thanos snap, maybe, where I'm saying that we can divide the community. For me, Fedor with Java is, how do you verify a property over it? I don't know. Do we need the least constitutability property in order to be able to usefully define formal property? Maybe. I have no proof of it.
If you're going to do verification and introduce contracts, you have to rethink what you mean by OO in that context. And featherweight Java just isn't in that domain. You can't just say that is it. You have to think what do I mean in that context. Anyway, I don't want to dominate the discussion.
So,
but I will just can I just ask
yes.
one other thing? I'm wondering, all these examples you had of issues to do with termination and not having base cases and so on, I'm wondering, is this actually because it's all really about co-recursion and we should be basing our reasoning on co-recursion and forgetting about termination and well-foundedness entirely?
I don't know. In some sense, I break stuff. I don't know why stuff breaks. So yes, before more technical question, one very important thing that I would like to discuss, is there anyone here that wants to organize or be part of the community for UNSOUND for next year, be part of the program committee? We have organized this, me and Jan, and we have called a couple of very brilliant people in the committee this year, but we need to establish, a committee that can take care of it year after year for UNSOUND to continue. So is there someone that may want to care about this, that may like to bring it up, in the future to organize UNSOUND 2023? Not alone, together with other people that will support it.
So I like the idea, but I don't know if I can commit to the time investment.
I understand. I think that's for a lot of people. Right. We really need someone that would like to, keep this alive. In particular, if enough people can keep this alive, then maybe I can be not part of the committee next year and I can actually publish as an author instead of just being an invited speaker. And maybe we need to have it every 2 years. I'm not sure, if there is enough content to break every year. Maybe we can break stuff every 2 years. So Ideally, at least, if you are interested, send me an email and we can try to make up like a group. And then from there we can take it, and we can see if we can figure out a way to sustainably be unsound. And part of this, what is the soundness unsound venue? This year we are here at Splash. Is Splash the perfect place for unsound? Is Popo a better venue? I don't really know. Which is the best place that can host us? I'm really open to hear suggestions. This year, it was very easy for us, given our background, okay, just I don't want to accuse anyone, but given our background, it was very easy for us to access to get, to talk with people from the functional verification community. We would like to be much more inclusive. We would like to reach people from the verified compiler community, people from verified toolchains community, from the deep verification community, and other community of verifications. So if you are in contact, if you can, send me a recommendation of people that I should invite as an invited speaker, or that we could consider to include in a bigger unsound community, please tell me. I'm definitely going to write him, but the more the merrier, And yes, this is, again, I think we can start being back on the more technical things. So yeah, please, write me with the people wanting to be in the community and people like nominating people, that may be in the community. It could be greatly interesting. So one thing that I think have been a little bit forgotten is about perverse incentives, in the sense that if we have unsound software verification, in a world where we are really strict on budget and many economic endeavors are very strict on budget, we may end up in a situation where maybe having verified code may make the industry people be more relaxed or less willing to invest millions of dollars into actual testing and auditing coding. So we may end up in a situation where this may sort of, backfire. Also, what if you start to think about security? What if you have a hacker submitting verified code to your open source verified project? Are you going to be as surveillant into checking that their code is actually correct? Or since the code is reporting to be verified, you are going to be much more trustworthy and just include it in your code base? And maybe this code is purposely exploiting a verification bug of some kind, and then it's using this code to do some security attack on code that use your verified library. This can backfire. We have to be careful. So, yes. Oh, and maybe someone didn't really understand me from the internet because I was talking there instead of here without a mic.
So the waveform showed up, so maybe you were loud.
Okay. So I'm just
so I just
loud enough.
To point out when you're talking about these incentives and backfiring. So I feel like if we published articles of the form X is unsound, it's quite dangerous, right? Because this is a publication you cannot take back, and it could increase sort of general paranoia of, well, nothing actually works anyway, so why bother doing verification at all?
I understand, but on the other side, this can happen. If we get to be successful in industry, this will happen. My code is verified. Why I should pay for code review and testing? This code is verified. I will accept it in my code base, unquestionably. And then it's going to fire back much more. If a nuclear power plant explode or the airplane fall off on verified code, it's going to make the paranoia that you're describing much, much bigger and harder to forget. That if the community honestly report on the limitation of the theory that we are designing.
But I sort of wonder if, as a model similar to vulnerability reporting with CVs, where there's a sort of drive to actually fix the bug before reporting it, and then make the publication might work for
I
people.
think this is okay if it's really an easy to fix bug. If it's something like, I believe the things I show are, where we need to come together as a community and discuss for years to somehow solve it, then no, I think we should publish it and we should come together to solve it.
I actually agree with whoops. Sorry, I actually agree that it's a bit tricky what you're describing, right? Because I remember in particular this paper, Java and Scala's type system isn't sound, right? Where they show that if you use null or some uninitialization problems, then you can trigger unsoundness in the Scala and Java type systems. And so I've seen people refer to Scala as, oh yeah, but Scala isn't sound, just because of this. Although in Scala, you just need to be a bit more careful about initialization, and you just need to rule out null, which people don't use anyway, right?
Also, is unsound, but
it's
it's
very
just
good.
going a cast error. That is very different from being
Yeah.
unsound with proving false and going on, with undefined behavior from that point onwards.
Well, it's on the JVM, so the unsoundness is not that bad, yeah. But it's been very harmful as a paper, right? Because this is not like a very important source of unsoundness. You just need to rule out no, which people already don't use. But I've seen people say, yeah, oh, but Scala is known to be unsound, as a whole.
I don't disagree.
Yeah.
But still, intellectual honesty have to come first.
Okay, but what I mean is that you can phrase these kind of things more carefully instead of wholesale saying, yeah, this is bad. You can say like, not being careful about this may lead to unsoundness, which implies that it can be fixed. Well, it can be fixed. In the case of Scala, it can be fixed, right?
Sure, that particular bug in Java and Scala probably can be fixed. Have they fixed it? No, right?
Yes, they have fixed it. There's a null safe option in the compiler of Scala 3, and Scala 3 is a lot more careful about initialization. So it doesn't, the initialization checker actually, if you enable it, doesn't let you write these kind of things. And an interesting thing is that in Scala, they always knew that there were problems with things like ghost variables and ghost code.
In Scala?
Yeah, because it matters in Scala. In Scala, you can use types that basically prove subtyping relationships using type members with lower and upper bounds. And so in Scala, if you try to, for example, use a lazy val, so a value that's lazily initialized, you cannot use the corresponding value as a valid path in a path-dependent type, because they realize that the lazy val evaluation may actually diverge, right? So in the type, you cannot use the lazy val as part of the.
And so yes, I understand how you connect with Ghost. Yes.
They do handle this correctly in the Scala 3 compiler. So that's interesting, maybe.
Probably have time for one more comment or question.
I mean, it's about the technique. It's about the technical thing from before, because most of the problems comes from well-foundedness and termination, right? And you show this issue with the fixed point, but you can define a fixed point like you showed list to list, parentheses to list with step indexing. Have you looked into that? Because that was one of the main motivation for that was recursive types, and there's a lot of things that it's a bit complicated, but typically what you get is a later modality, and you can do contravariant recursion, the things you were doing, but one step later, and one step is really like one step, let's say, next step in the code. And in this case, you cannot use a contract that is going to be available one step later, right? And it forces well-founded recursion. And that might be an answer to several of the things. Yeah, I don't know if you looked at that.
At this stage, I'm trying to purposely not look into solutions because I just want to collect problems.
Yeah, but the question is it actually a problem if you use step indexing in the context of contracts, right?
I don't have a proof that there is no way to twist the current state of the art and to add more and more thing up to the point where it's actually sound.
Okay, maybe I can put it another way.
Yeah.
There are two types of communities in a sense, or two types of works in the verification community, right? There's automated verifiers like Daphne, purpose built on Viper Key that have unsomenesses, and it's kind of a trade-off because you want to make progress, you want to automate. You have issues that are known, but it's like when you develop a software, right? You know there are bugs, but you cannot spend all your time. And the point is that these unsomenesses are known. There are research tools before being like tools where you go into your company, you say it's verified, I'm 100% sure, but there's a part of the community that does foundational verification things that you prove sound in Coq, in Isabel, or something. Iris is an example of that. They use step indexing. So the question is, could you actually break, in a sense, these things like that are actually done in with foundational tools? Because here, these things are because it's prototypes, right? That we have these unsomenesses.
So yes, what I will discuss here are all well-known issues by some. I have talked with many youngish researchers in verification that have published on, Daphne, not in the sense of I'm developing Daphne, but I'm using Daphne, to support my research in blah, blah way, that are absolutely unaware of these kind of problems. So some people in the community are aware of those limitations, and they are aware that those tools are broken in these kind of ways, but the just societally extended community, the people that are using Daphne as a tool in their research to make more research are not. At least many of them are not. And this worries me. We need more communication about the limitation of the verification tools so that the community at large is aware of it, so that they can make correct statement when they talk about their research that uses those tools in various ways. And the problem will only get worse when you go to industry, where people don't even have a PhD. And in general, the only reason they care about what they are doing is because give them money to feed their family. They don't actually think that what they are doing, have a value out of itself, maybe. So they will be even less motivated to go and discover those problems.
So maybe lots of discussion for later in the evening.
Yes. Are we at time?
We are at time.
So, yeah, well, so we're out of time, right?
Yeah, we are at time. I'm not running away.
Okay.
Everyone that wants to stay is welcome to stay, but we do have a coffee break.
Okay. So, anyone is free to go to the coffee break, but I had a question about your previous slide, actually. Do you want to discuss it now?
Well, sure.
So about the second problem you identified, the one with the true and false classes. Yeah.
This one?
No. The other one. The C2 and C4.
Yeah, it's coming. Yeah.
Right. So this one. So I think this is actually a much simpler problem. It's not really. It doesn't fundamentally rely on non-termination, right? So the thing here is that, okay, you have several ways of thinking of objects, right? The most basic way that is not powerful enough to think about objects is that as structures, collections of methods, collections of functions, right? Collections of lambda functions, okay? So to make it powerful enough, you need these functions to also take a self parameter, right? And this is where you get into a lot of trouble. But for this one, you don't need a self parameter, right? The interpretation as
That's why I'm
collection
so
of something.
confused about this example, because
Well,
it's
but-
so
but-
simple,
but
it
this-
doesn't use this. it
Yeah,
doesn't
because
use-
what this example does is it says, it tries to ensure something about a function that is completely arbitrary. C.com here is an arbitrary function essentially, right? So you cannot say anything about it, obviously.
I understand, like, of course, you look at it and you realize that this should not verify.
Yeah.
However, how do you implement a verifier that recognizes this without also cutting things that you want to keep, in some sense? And by the way, I have evidence of talking with people trying to encode this and trying to prove it correct for quite a while before they discover it was broken. In particular, if you only show the see-through side, then you get the people looking at it, of course, come on, it's no. It's only when you show both sides that is so obviously wrong, even for a human proof engineer, And again, suppose that you are not really taking a C, that you're taking a D, and the contract doesn't really talk about talk about another method. In the mindset of for verification, how do you understand the meaning of calling another method? You look to the contract of the other method. And if you just do it, you can do the proof in the style that I described there.
Right, but the contract it doesn't make sense. Yeah.
I agree.
Yeah, okay, so.
How do we write a...
Yeah.
No, but I don't agree. I think the contract makes sense. It's the proof that is not well founded. Here it's really, if you think about the proof, how do you prove this thing? You prove it by using the other contract, how it's been proven the other contract. And it's again, you have basically something that, like the contract makes a lot of sense. It's something that you would like to write. It's something that could actually work. If you can prove, like if you just have that your interface actually, or let's say it's a final method or something, you just return true. This, you know that everything is always going to return true. You can prove this thing.
So if it's a final method, of course, right?
Yeah, no, but what I mean is that the contract makes sense. It's just the proof. That's the problem is in the proof, not in the contract. This contract shouldn't be you shouldn't be able to prove it from this.
Yeah, that's why it doesn't make sense. Right?
Why would you believe that worked anyway? When you've got.
To me, it was obvious it wasn't going to work, but while discussing with people on Zoom and asking them, can you do this? I got a lot of people actively trying for a good half an hour until I show like the other version and they start getting it.
Is this something you can prove with existing verifying?
Yes. So
Really?
this, if you give it to key, exactly like this, no. But if you make two common methods jump with each other, we have seen the same thing in your presentation, where to break key, you needed to have recurse 1 and recurse 2 that jump within each other. So if you do the same exact trick of duplicating com, key will happily accept this.
Well, okay, but then you're in a different example, and it's not the kind of commutativity that you started talking
Sure,
about.
but
Right?
it's
So, and the thing is here, you've got subtyping happening on your argument and your receiver, and I'm going to ask you, is this coherent, whatever, and where's the proof rule that allows you to do that? You've got subtyping in here, and there's just no I see no reason to.
So let me try.
I can't imagine any.
Yes, let me try. Let me try to do what you said. So, how do I prove this statement? So, in the extension of OR logic with the function calls and clause inside of the contract, to understand the meaning of a contract that has a function call, you go in the place of the definition of this other function and you unfold it. However, that extension, that is sound, works when you have top-level functions. And the function that you are proving right now, you cannot use it. Here,
you know, this is not.
Is COM the function we are
You've
proving?
got
Yeah.
subtyping going on here. These are not both direct instances of C. They're instances of a subtype.
Exactly.
So if you're going to start introducing an argument about what function you call in and